The Dura Mater exhibition started, the work for it started in late 2019, and so much has happened since then. We've worked with artists and scientists through COVID-19, and we've created a beautiful body of work between all of us. I'm very proud of what the artists have done and learned so much. Art and well-being are very strongly linked, and of course so is science and well-being. So maybe you can tell us a bit about what your feelings are in this show, and maybe even talk about some of the work here.
Absolutely. So yes, no, I think those two things are very much interconnected, just like art and science are very much interconnected. People tend to think of them as two completely separate things, and artists can't be scientists and scientists can't be artists, but it's totally not the case. There is very much, if we think about science, there's very much an art to what we do. There's a definite aesthetic component to what we do, and you can see this if you look at scientific papers, the images that you see through microscopes. And by the same token, artists work in a very precise manner. Things are very measured. Things are very calculated at times. In fact, math and physics are often used in art. So I don't see them as two separate things. They flow together. They influence each other. They are really one and the same. And then when we think about how art lends itself to well-being, well, we're here in St. Boniface Hospital, and this is really a place for patients and staff to come and take their minds off of some possibly very weighty things that are weighing on their mind at the time. It's a chance to reflect and relax and just appreciate these beautiful things that these artists have created. And then, of course, many of these works are related to the work we do as scientists, and most of us are working on diseases like Alzheimer's and Parkinson's disease, trying to find new treatments and trying to help improve people's well-being through science. So I think both the art and the science are coming together in this exhibition to promote well-being.
This is a very important show for the St. Boniface Hospital. The Buehler Gallery is a place of hope, healing, and contemplation, and if we can do it by exposing people to art and getting them to think about science in a new way, I think we've done something very positive. And we see that exemplified in some of the work here, don't we? This is the work of Bonnie Marin. Yeah, quite beautiful.
It is, and I feel very much at home here because, as I mentioned, I'm in the Department of Human Anatomy and Cell Science, and most of my teaching is in anatomy, human gross anatomy, which we teach to our medical, dental students, all of the health professional students at the University of Manitoba. So I could go through many of the muscles that we see here. We'll save that for another time, but I think what Bonnie has done here is absolutely stunning. And you can see them almost as these Freudian anatomical dreamscapes. It's a reflection of what we see in our brains. If we go back to the theme of neuroscience that we were exploring here, this is all about imagination and possibility. And you can see that reflected in the art. Science can be so intimidating for people. If they don't have a scientific background, they see this monolithic, huge thing called science, and they feel overwhelmed, and they don't sometimes feel comfortable asking questions. They think, oh, I don't want to ask. I don't want to appear silly or unintelligent. And so we want to dispel that notion. We want to invite people in. And again, art is a wonderful way to do that by engaging with people through these different media. And we have all kinds of different media here in the show, which is wonderful. People can make that connection, and that serves as a starting point to ask questions, to learn more, and we can educate people through this. And there certainly is a lot of misinformation out there right now, and so this is a chance for us to reach people and tell them about what we do so that they understand what is really happening in science and what real science means.
To have the artist interpret it in such a way that is gripping and powerful and really speaks to the soul is wonderful.
That's exactly what we want to accomplish, and I think we've done that through this show.
I had no idea that the brain and the spinal column had so much to do with each other and work together. Can you tell us a bit about that?
Yeah, absolutely, Leona. Well, they're actually part of the same system. They're all part of the central nervous system. The brain and the spinal cord are what form the central nervous system. And one of the interesting things about Julie's piece here is that we see the spinal cord here hanging from the brain. They're attached to the ceiling. And then branching off of that, we also have this series of spinal nerves, and these form what we call the peripheral nervous system, going out to the periphery of our body. The really interesting thing is, and I don't know if Julie meant to do this, but this is actually almost to scale here. If we think about the innervation, say, in the sole of our foot, say the bottom of our big toe, and you feel something, a vibration, or if you step on a piece of Lego like many parents have, those sensations are carried from your big toe all the way up to the spinal cord, just below your ribs. So the nerve fibers that are carrying those signals are well over 1 meter long in most people. So as I said, these fibers that we see here in Julie's piece are actually close to actual size. The spinal cord's made up of 5 different segments: cervical, thoracic, lumbar, sacral, and then there's a small coccygeal part at the very bottom, which only real anatomy nerds like me worry about. But we see those 4 different segments represented here. And Julie has talked about how these different nerves are going to different parts of the body. So what we see here in the monitors are these cervical, thoracic, lumbar, and sacral segments. And so each of these controls a different part of the body. So if you were to turn your head and to look at the baby here on the monitor, you would be using those muscles that are innervated by the cervical spinal nerves. If you were to be jogging down this street and you felt yourself breathing in and out, it's the muscles in the thoracic region that are controlled by these nerves. And by the same token, if you were walking along the beach where that lake is in the bottom monitor, or walking towards the people in the third one, it would be the lumbar and sacral segments that are controlling that locomotion, that walking movement.
That's quite incredible, isn't it? That a piece of art and the neuroscience that is attached to it could be interpreted in a way that is both fascinating, non-sciencey, and will appeal to such a wide audience and hopefully help people understand, and with younger students, hopefully get them interested in science.
Absolutely, that's why we're here, and art can convey this in a way that a picture in a textbook never could.
Education as part of the exhibitions we do is very important for the Buehler Gallery and for this show, perhaps more than any that we've ever done. What's your take on that?
Well, that's exactly the mission of the Manitoba Neuroscience Network, Leona. We are here to help promote awareness of neuroscience in the general population, to help people understand how science is done, what science means, how science impacts our lives. And as I've said in one of our previous conversations, what better way to do that than through art, something that people connect with very easily and very emotionally as well.
Yes, people can certainly connect with it on an emotional level, and I think it draws in a new audience, and it allows that audience to understand the message in a new way, where we're not using words, where we're getting directly at the emotional aspect of the work.
It's true, it allows us to confront some potentially difficult subjects in possibly a softer way. One example is the subject of FASD, which Janet Shaw Russell has covered in her work. FASD can be very devastating. But one thing I want to mention in that vein of education is that FASD is the only neurological disorder that is 100% preventable. It's as simple as that. If you do not drink during pregnancy, FASD cannot happen. So I hope that we can help to get that message out there in a slightly different way and possibly reach a few more people.
I hope so. That's a stunning and important message. Thank you, Sari. And we are going to take a close look at Erica Lincoln's sculpture, Neural Knot. This neural knot is beautiful. The way she has used her different materials, from wires to threads to pieces of yarn, and created areas that you probably don't know are actually hiding small microphones. So we see serger yarn here in beautiful colors. very carefully unwinding itself and heading into the neural knot. And the wires are being dragged over the microphones. People who hear differently sometimes don't experience what the person speaking is saying the way it's intended, and that's illustrated here on this spindle where the threads are being gathered, and we can certainly see that they're being gathered in a way that's very different and sometimes almost random to how it came off the serger spools on the other end.
Yeah, it's true. And you can see some aspects of pathology reflected in this piece as well. Whether that was her intention or not, that's okay. But as a neuroscientist, when I look at this, I can see some aspects of pathology. It's appropriate that the title is neural knot, because one of the things that's very characteristic of Alzheimer's disease is something called a neurofibrillary tangle. And these are tangles of toxic protein that form in the brain that kill neurons. They often affect the temporal lobe, which is also associated with memory. That's responsible for the memory loss that we associate with Alzheimer's. You can also think about what happens after a stroke. And so when an individual has a stroke, often a certain function is lost. And if you think about those different areas of the brain that I mentioned, it could be vision or hearing that is affected. So you can picture through this sculpture how information is being received by the brain, but if there is pathology, it can be interpreted possibly in a very different way, or sometimes not at all. The sculpture, as I mentioned, can be interpreted in many different ways, but Erica's intent was really to explore auditory processing disorders, and I can't think of a better way to encapsulate that kind of message than in this piece.